Let's start chapter number 17, Static Electricity. Static electricity is all about charges, positive charges and negative charges, the electrons, and you see that how the charges attract each other and how the charges repel each other. Let's talk about electrostatic force. Positive charges, similar charges, they will repel each other. Opposite charges, they will attract each other. What is static electricity? Static electricity is build-up of electric charge on an object due to an imbalance of electrons. Static means charges are not moving, unlike current electricity. Types of electric charge. There are two types of electric charge. Positive, the symbol is plus, meaning loss of electron. Negative, the symbol is minus, means gain of electron. The rules are like charges repel, unlike charges attract. Electron move, protons do not move. Charging by friction means rubbing. When two isolating materials are rubbed together, what happens? One object gains electron, becomes negatively charged. Other object lose electron, becomes positively charged. Example, plastic rod plus dry cloth. Plastic rod becomes negative, cloth becomes positive. Mass does not change, only electron moves. Charging by induction without touching. Charging by induction happens without direct contact. Steps: bring a charged object near a conductor. Charges inside the conductor rearrange. Earth the conductor, electrons flow. Remove earth, then remove charged object. Conductor remains charged, used in metal objects. Now let's talk about insulators and conductors. Conductors allow electron to move and insulators do not allow electrons to move. Metals, copper, aluminium are the example of conductors. Plastic, rubber and glass are the examples of insulators. Static electricity builds up more easily on insulators. Let's talk about electric fields. An electric field is the region around a charged object where another charge experiences a force. Direction: from positive to negative, stronger fields to closer lines. Drawing arrows shows pointing away, which is positive, and towards, which is negative. Now let's talk about gold leaf electroscope used to detect charge, identify charge type, compare amount of charge. How does it work? Charge added, electrons repel, gold leaf diverges. Greater divergence means greater charge. If leaves collapses, object discharged. Let's talk about earthing, discharging. Earthing removes excess charge by allowing electrons to flow to the earth. Why earth? Earth is a huge charge reservoir, neutralizes charge safely, used to prevent sparks and explosions. Dangers of static electricity: sparks near fuel vapors, lightning, damage to electronic components. Real example: fuel tankers uses earthing wires to prevent sparks. Use of static electricity: it is used in photocopiers, inkjet printers, sprays painting, and electrostatic precipitators. Remove smokes. Lightning application. Lightning is a huge static discharge between cloud to cloud, cloud to earth to cloud, occurs when charge builds up become too large. When a plastic rod is rubbed with a cloth, what happens? Electron transfer from the cloth to the rod. Then the rod becomes negatively charged and the cloth becomes positively charged. Like charges repel and unlike charges attract. Let's talk about electron transfer. Electron transfer is the movement of electron from one object to another, usually during rubbing or contact, causing objects to become charged. Only electrons move, protons remain fixed. Let's talk about charge imbalance. A charge imbalance occurs when an object has unequal number of electrons and protons, making it electrically charged. More electrons, negative charge; fewer electrons, positive charge. Let's talk about repulsion attraction. Repulsion, when two objects with the same type of charge push away from each other. Attraction means when two objects with opposite charge pull towards each other. Like charges repel, unlike charges attract. Now let's talk about insulator, conductor. Conductor, a material that allows electrons to move freely. Example, metals. Insulators, a material that does not allow electrons to move easily. Example, plastic and rubber. Static electricity builds up more easily on insulators. Earthing. Earthing is the process of removing excess electric charge by allowing electrons to flow safely to the earth, used to prevent sparks and electric shocks. Let's discuss what is electric field. An electric field is the region around a charged object where another charge experiences an electric force. Field direction is from positive to negative. What are static discharge? Static discharge is the sudden flow of electric charge from a charged object to another object or to earth. Example, sparks, lightning, small shocks. Static electricity occurs due to electron transfer, creating charge imbalance, which causes attraction or repulsion and may be removed by earthing through static discharge. Let's practice some questions. Explain how an object becomes charged by friction. When two insulating materials are rubbed together, electrons are transferred from one object to another. The object that gains electron becomes negatively charged, while the object that loses electron becomes positively charged. This creates a charge imbalance, causing the objects to become statically charged. Only electrons move, protons remain fixed. Another question can be why plastic builds up static charge easily. Plastic is an insulator, so electrons cannot move freely through it. When plastic gains electron, they remain trapped on its surface instead of flowing away. As a result, static charge builds up easily on plastic. Let's discuss another question. Describe how a gold leaf electroscope works. So the answer is a gold leaf electroscope is used to detect and compare electric charge. When a charged object touches or is brought near the metal cap, electrons move through the metal stem to the gold leaf. The gold leaf and stem gains the same type of charge, so they repel each other, causing the gold leaf to rise or diverge. The greater the divergence, the greater the charge. When the electroscope is earthed, the leaf collapses as charge is removed. A shocking phenomena, lightning and electrical sparks. So you can see here discharge within cloud between negative base and positive top, intracloud. Here distance between the negative and positive areas of two clouds, intercloud. Discharge between the negative base of the cloud and the positive ground below it, cloud to ground. That's how it works. So we have here the sequential breakdown events at each pair of electrodes. This is also telling you that how the charges are flowing. Now, core concept: lightning and electrical sparks are caused by large buildup of electric charge, which creates a very high potential difference. When this potential difference becomes large enough, air breaks down and conducts electricity, leading to sudden discharge. Key definitions that we need to learn: electric charge, a physical property of matter that causes electrical forces of attraction or repulsion. Charged buildup, the accumulation of excess positive or negative charge on an object. Potential difference voltage, the amount of electrical energy transferred per unit charge between 2 points, measured in volts. Electrical breakdown of air, a process in which air becomes conductive when the electric field is strong enough, allowing electric current to flow through it. Electrical discharge, the sudden flow of electrical charge through a conductor or through ionized air. Example, spark or lightning. Lightning explain the process. These all you have to understand and you have to learn also, as it can be tested in the exam. Step by step, inside a thundercloud, charge separation occurs. Top of cloud becomes positively charged, bottom becomes negatively charged. This creates a huge potential difference between cloud and earth, or between different parts of the cloud. When the potential difference becomes extremely large, the electric field strength increases. Air molecule ionizes, air breaks down and becomes conductive. A massive electric discharge occurs, which is called as lightning. So that's how the lightning occurs. So understanding and remembering the steps are very crucial for the examination perspective. Now let's talk about electrical sparks are mini version of lightning. Occur when charge build up between two objects. Air breaks down, a sudden discharge happen. Example, static shocks, sparks from damaged electrical equipment. Why lightning is dangerous? Extremely high voltage. Very large current can cause fatal electric shock. Can damage building and electrical systems. This is why the lightning bolt symbol is used as an electrical hazard sign. Now let's talk about Benjamin Franklin experiment. What he did. He flew a kite into a thundercloud, attached a metal key, used a ribbon as an insulator, observed sparks and raised fibers. What it showed. Lightning is a form of electricity. Charge can flow from clouds. Why it was dangerous, risk of electrocution. The metal key could alter the electric field. Now, let's discuss about charging and discharging. Static electricity is commonly experienced in everyday life. Sparks when removing clothes made of synthetic fibers, small shocks when exiting a car and touching metal, a rubbed balloon sticking to a wall or hair. When a plastic object, example a balloon, is rubbed with a cloth, both become electrically charged. This can be observed by their ability to attract light objects like hair or small pieces of paper. This indicates that static electricity is generated by friction, and a charged object can attract uncharged object. To systematically investigate forces between charged objects, consider the following experiment. Rub a plastic rod with a cloth charging both. Hang the rod in a cradle. Bring the cloth closer to the rod. The rod moves towards the cloth, that is attraction. Rub a second rod in the same way and bring it close to the first. The hanging rod moves away, repulsion. These observations demonstrates the existence of two types of static electricity. Since both rods were treated identically, they are presumed to have the same type of electricity, while the cloth and rod must have different types. These two types are referred to as positive charge and negative charge. When rubbing, one object gains one type of charge, example negative on the rod, and the other gains the opposite type, example positive on the cloth. The fundamental rules for forces between electric charges are, therefore, Positive charges will repel each other, two negative charges will repel each other. A positive charge and a negative charge will attract each other. The rule is similar to magnetic poles, like poles repel, opposite poles attract. But it is crucial not to confuse magnetism with static electricity. Magnetism arises from magnetic poles, while static electricity arises from electric charges. For example, a child's hair standing on end after bouncing on a trampoline. The friction between the child and the trampoline causes the hair to become charged. Since individual hairs are repelling each other, it indicates that all hairs have acquired the same charge type of charge. Similarly, walking on a nylon carpet can cause a person to become charged through friction, leading to a small shock when touching a metal door handle as the charge discharges. Now, investigating static electricity. This experiment involves charging materials and observing their behavior. Take materials: polythene, acetate, glass, rods, cloths of different material, paper strips, fine thread, clamp and stand, watch glass, balloons, tiny pieces of thin paper. Now, getting started. Determine the amount of rubbing needed to charge rods by testing their ability to pick up small pieces of paper. Method: set up rods to turn freely using a paper strip or watch glass. Rub a polythene rod with a wooden cloth along with full length, then hang or place it. Rub another polythene rod and bring it near the first. Observe if they attract or repel. They should repel. Rub an acetate or glass rod and bring it near the hanging polythene rod. Observe if they attract or repel. They should attract. Experiment with different rod combination and fabric types. Given that the polythene rod rubbed with wool gains a negative charge, deduce the charge gained by the cloth and other rods based on attraction repulsion. Inflate and rub a balloon. Determine its charge by testing against known negativity charged polythene or positively charged acetates. Some discussion questions: if two rods attract each other, it does not definitely prove that they have opposite charges. A charged object can also attract an uncharged object. To prove that two rods have opposite charges, both rods must be confirmed to be charged. This can be done by testing each rod's ability to attract small uncharged object. Then if they attract each other, it confirms they have opposite charges, as they are both known to be charged. Alternatively, one rod could be tested against an object with a known charge, example, a negatively charged polythene rod, to determine its charge, and then the other rod could be tested against the same known charge to see if it behaves oppositely. So, explaining static electricity again, the ancient Greek observed that amber, fossilized tree resin, could attract small pieces of cloth or hair when rubbed. While they and Benjamin Franklin lacked knowledge of electrons, so they still developed an understanding of static electricity. The concept of electron simplifies the explanation of electrical phenomena. So, charging and friction. Friction is the force that causes charging. When materials are rubbed together, tiny particles called electrons are transferred from one material to another. Electrons are negatively charged and are located on the outside of the atom. The nucleus in the center of the atom has positive charge. The neutral atom has equal number of positive and negative charges. Outer electrons are relatively weakly held and can be pulled away by friction. When an atom loses an electron, it becomes positively charged. When an atom gains electron, it becomes negatively charged. These points are very crucial to remember in the exam. Charging is always result of gaining or losing electron. Positive charge itself is not transferred. Example of polythene rod, we have already discussed that when rubbed with the cloth, how does it flow? Similarly, static electricity requires two different material, with one becoming positive and another negative. Conductors and insulators also we have discussed, so there is a quick revision for them. Summary of polythene rod charging is again given. When a polythene rod is rubbed, electron moves from cloth to rod. This means rod becomes negatively charged and cloth become the positively charged. An acetate rod becomes positively charged by losing electron when rubbed. Electrons are transferred from acetate rod to the material. It is rubbed against, leaving the acetate rod with a net positive charge. The difference in charging between a polythene rod and a metal rod like copper when rubbed is due to electrical properties. Similarly, we have discussed about insulators, conductors. There is a short revision for the overall processes, the types of charges, positive, negative, neutral. We have studied the law of electrical charges, like charges repel and opposite charges attract. Atomic base of charge, proton, electron, and neutron. Quantization of charge. Electric charge is quantized, meaning it exists in discrete, indivisible units. The smallest unit of charge is the elementary charge and is denoted by E. The charge of a single electron is negative. The charge of a single proton is positive. The value of the elementary charge E is approximately 1.602 times 10 power 19 coulomb. The coulomb is the standard unit of the electric charge. Any observable electric charge Q on an object is always an integer multiple of this elementary charge. Hence, n is an integer. So, positive negative representing the excess or deficit of electron. Conservation of charge. The principle of conservation of charge states that total electric charge in an isolated system always remain constant. Charge can be transformed from one object to another, but it cannot be created or destroyed. For example, when rubber rod is rubbed with fur, electrons are transferred, not destroyed, from the fur to the rod. The rod gains a net negative charge and the fur gains an equal net positive charge. Both the total charge on the rod fur systems are remain zeros if they started neutral. This principle is fundamental to understanding all electrostatic interactions. With this, we have finished our chapter. See you in our next chapter.